everyone. Great to be around. I assume, how many of you have used Spring AI? So, I guess so, almost everyone. Cool. We're going to talk about how very small concept actually can help you build almost any complex agentic pattern out of it. So, and if you start with very simple use case, every one of you have familiar, you're going to pass and use LLM, you're going to send the context, get some feedback, try to improve it, and loop over until you get the response that you expect to be useful for you. It is the kind of relentless loop to get there. And I'm kind of, I really like this blog post by Raphael a few days back or last week, where not many people, maybe everyone now realize that when we talk about generative AI, it's not really about training model or using, it's more like how to use this model like a black box or like something that you can use. It's intelligence, it's very useful, but how can actually we can make use of it in our system to provide the proper validation, proper quality. Quiet, be quiet. And so if we're about to talk about how to use this black box in our systems, it really helps to understand what those black boxes are actually, what are the important characteristics of this black box. Statelessness is one of the most important bits. Also, those models have been pre-trained up to some point in the past. That's another important thing we have to consider. Text in, text out, non-structured response, and then non-deterministic, which is good. They're creative, but also they can be hallucinating, which is not that good. And finally, it's very important to realize that we have a limited amount of data that we can get in and get out in a single pass, single turn, and it's measured in tokens. So having this in mind, and we mentioned it's stateless, how we're going to build a stateful application or maintain state in your conversation. Again, it's straightforward when you start looking into this black box part. You have to intercept your communication to the LLM, append the question to some sort of memory storage, and send to the LLM not the question itself, but the user question along with some preset of history from the previous conversations. You need a subset of this, and you should also intercept the output and append it into the conversation history or memory in order to enable the follow-up conversation and to support this. So if you look into this, it is this intercepting the input and the output of your black box. And this is the typical concept of interceptor or advisor or hooks you can think of. It's nothing new, or filters if you're coming from the web background. And this is how we are doing it. Spring, you have this concept of advisor or interceptor that allows you to intercept and augment what gets into the OM and what gets out of the OM. And this is the typical implementation of the chat memory advisor. And having this, I intended to show actually the new session ID implementation. We have a new stuff that we have just starting incubating and preparing. Maybe I would show the demo, but it's the same principle underneath, simply slightly different implementation. And this is indeed the general concept of advisor. It's the most powerful bits that you should memorize from this conversation, because we're going to build almost everything on top of this simple concept from now on. So again, we have the ability advisors is this piece of code that you can put on the path of your interaction with the LLM in and out, and it allows you to augment the input and output of your LLMs of the information that gets in and gets out of the LLM. So let's look into another use case that maybe this would be useful as well, how we actually can make the LLM answer questions that are relevant to some recent domain or something that is that's relevant to your particular enterprise. And this always falls into this context of this group of context stuffing or RAG, general pattern, which on the surface means something, looks something like this. Your user asks question that is not known to the LLM. The LLM has been pre-trained to some point in time in the past. So you are supposed to pass some additional context that would inform the LLM how to answer your question in this particular domain of knowledge that you want to ask the LLM to provide you with support for. And the typical ways to do this is to either inject the entire static files or static information. If you can fit it in the context, again, we have to be mindful that we have a limited amount of data that we can pass in and out. Or you're going to use one general concept where you're going to preload this information you're interested into some external storages. It could be regular databases, graph databases, full text search, or most common cases is semantic search-based system where it's vector store embedding. This is not, again, the purpose of this discussion today. Here is the guy, Thomas Vitali, who contributed very advanced, you're here. So who contributed very advanced modular rack support for Spring AI. What is interesting to stress out here is the way to handle this under the service, again, the same pattern. We are intercepting the input, and practically how it works, the user input is actually passed, and we use the user input as a query to figure out what are the most similar chunks or entries into our existing vector databases, and retrieve those and stack it in our context on the way to ask the LLM. Another interesting point, which would return to later on, we are doing this injection of stuffing up front before consulting the LLM. We are trying to be smart. We're trying to figure out what is the most important piece of information related to this context, judging only by the user question. In some advanced cases, it can actually elevate these bits, but the principle is the same. We are doing this without consulting the LLM. It's not agentic in that sense. Another class of problem is, again, the LLMs are not deterministic, so they're not predictable. And the most common way to try to control them is to put some boundary in the input and output. This is falling in the realm of guardrails. Practically, you're going to implement some sort of logic before you send the message to LLM, or you're going to put some sort of logic that would decide whether you're going to forward the response to your customer or not, if the LLM have provided a satisfying response. So, very quick example. How are we going to do this? You imply this pattern if you want to provide some sort of sensitive word protections. You would like to prevent sending sensitive words to your LLM, assuming that maybe, or it could be a sensitive word, or it could be passwords or some additional information that should not get out of the realm of your enterprise or your company. Very straightforward, and this is very simplistic example. Let me go. And I forgot, guys, to show you all the demos along these bits. That was the main purpose of these questions, but I would walk you through. So the chat memory. And this would give you some, we discussed about the chat memory. Everything you have to do is to put this advisor, memory advisor, in your path. So without this, if you try to, so what we're doing, we have ChatClient, we introduce ourselves, and we ask what our name is. So the responses would be, I don't know, which makes sense, it's stateless. If we plug this, anyway, all those examples, most of you have used ChatClient already. I presume you're pretty familiar with this concept. I would kind of rush because there is much more interesting high-level abstraction that I would like to cover. But now, yeah, it knows my name. Similarly, I introduced the concept of rack, and this is the naive rack implementation. In this case, I'm practically injecting some additional information. This is some information for some, I downloaded Wikipedia. Normally, you're going to preload this offline, and at runtime, you're going to use this advisor that is going to perform the rack for you, so that everything that you have to do is, and there is a different implementation. This is the most naive one, and this question would be answered with information that is additionally injected from this advisor. We can even see that what you see in yellowish color here is practically another advisor that intercepts the input and output and it prints out some important information to help us understand. So we send this to the advisor, so apparently the rack injected some additional context, and then we got relevant information back. I covered the I have covered the simple advice. I'm even going to skip this example because there is much more interesting example about another guardrails. So this one is just asking, checking if the content has some sensitive words. If not, the question is going to be forwarded to the context. If yes, it's going. If there is actually something sensitive and detected, this communication is going to be abandoned. But let's see something much more useful. Guardrails when you want to actually interrupt and check something about the output of the LLM. And Spring AI has been supporting structured response. This is another limitation of the LLM, the text in, text out, unstructured, but with Spring AI, you can support enforce structured response on different levels. The most simple one to do it, and actually how it works under the cover, let's say that the user, instead of simple text, asks the response that is in certain type format. The Spring AI is going to convert this type into a JSON schema, automatically inject it into your, again, intercept your input, augment your context, and ask LLM politely to actually provide the response into this particular format. Most of the time, LLM is going to provide the response into this format, you're going to convert it and send it back to the user. What would happen if, in this 1% where actually the LLM does not provide the right format, this happens, let's say 1% of 100, one time of 100, and what would happen, the user is going to see error message itself, and it has to have, it would be some conversion error, so this JSON actually doesn't comply with the schema, we're trying to convert it, and it would fail. So how we can solve this with using now this concept of advisors, it's yet another advisor you can plug on our path, and in this time, it actually intercepts the output, and the output is here, it checks whether the text is compliant with the schema that we would want to validate. If yes, everything's good, we can go forward. If not, we're going to just send, and this is the interesting bit, so we're going to send back additional feedback information, put it in the context, and ask the LLM again. And most of the time, second attempt is successful. And what's more important is that this actually is happening without the involvement of the user explicitly. So let's see how this looks in code. Actually, Spring AI provides this advisor out of the box. It's called Structured Output Advisor. And what we want to achieve here, we have this actor films. This is our desired type. And this is how in Spring AI we're saying, instead of text response, please provide the response that is compliant into this format. And we're asking generate the filmography of 5 movies by Tom Hanks, for Tom Hanks. What is happening here, actually two interesting bits. First, this is a new addition to the Spring 2.0. You can opt for the structured output native format. Many of the AI models nowadays and the APIs for these models, they started to provide this capability of structured output built into their APIs. So in Spring AI, trying to be a portable abstraction across all these different providers, if the AI provider support these capabilities and you have enabled this feature, it is going to opt and try to use and ask the API's feature for this structured response. If it's not available there, it is going to fall back to this general behavior that I have showed. It's in 99% of the cases, it's still going to fulfill this capability. But in either case, if the response is not compliant to the schema, this would be an error message. So what you can do in addition is inject this advisor, as I showed earlier, and this should be enough to provide the response into the structured, to ensure that, and you can configure it how many attempts you need to do, but the important thing is that, okay, this is the wrong demo, run this guy. Again, the idea here I'm trying to implant and to suggest here is the structured response that we're using over and over the same kind of approach to either handling the input and output. And what is interesting here is that we have actually this feedback line. We have this loop that goes back. So it's an advisor that actually does something extra. And if we want to extend on this approach, this is another advisor, while this one, actually the previous one had kind of a deterministic logic to check what is the output. This one uses LLM, it does again guardrails on checks the gate out, but actually you can use another LLM to check the correctness of the response for the first one and make some actions. So in this case, you can check, that's very common things, does this response complies or answers the original user questions? So the judge LLM say yes or no, usually some writing, there's a structured response to do these bits. If yes, we are happy you're going to send the response back to the user. If not, the judge AOM is going to provide additional information that we're going to inject into the original context along with the original context and try to improve the response again. And again, this is something that can happen as a loop automatically while actually do it, you're trying to improve. And there is different way to do this, this implementation. Most of the time, you're going to use a dedicated, smaller, fine-tuned judge AOMs, which are trained to not be that biased and can support ranges. Hugging Face actually provides a live board that you can use to export this information, to select such models. In code, it would be yet another advisor that you're plugging into your pipeline. And this is an interesting example. I deliberately have a tool that returns, and I'm running a little bit out of time, but everyone knows what tools is, I guess. So we are registering a tool that provides real-time weather information. I deliberately, I'm going to generate kind of not realistic information for 2/3 of the cases. And I have this self-refined advisor that is staying in our loop, and we're going to run this to see how it looks. Okay, we were lucky. We have a negative temperature. Now I assume that the advisor, the judge AOM is going to detect this response, and before actually returning to the user, it is going to try again. Okay, even the second attempt was unsuccessful. Hopefully the third one would be successful. No. And because we have only, I think, only 3 attempts, it failed. I can run it again, but if it's successful, it would have, but you get the idea. So practically it's trying and it's doing all this on behind. What you're paying as a user is additional latency and more loops that go back and ahead. But anyway, if you want to implement this, to handle this situation, you would have to do it yourself in your own code. So this is just easy way to plug this behavior as an advisor into our part. And another interesting story, in the past when we started Spring AI 3 years ago, we were discussing about prompt engineering. That was the big theme. Over time, it was realized it's not about the text, it's about the whole metadata that gets to the model. So we started to talk about context engineering. And now the new hype is harnessing, agent harnessing stuff. And what is harnessing, no one can tell you, but that can tell you what is not. And the best definition I've heard is everything that's not the AOM is harnessing. So officially Spring AI is a harnessing framework as well. So everything I can build in order to provide useful information, use the AOM for some purpose, is a harnessing as well. So this, and the advisor is a very elegant way that you can provide harnessing logic into your existing pipelines. Again, this is the interesting bit. So we had this advisor that allows you to return some feedback back to the user, back to the original context, and try again. Tool calling is another example that can be implemented as an advisor, and it should be implemented as an advisor. Historically, it was in Spring AI, it was implemented in very low layer into the chat model, which made it almost impossible to perceive and observe what's going on there. So we always had this problem and tension. I would like to have this hook, I have to have, and we had a lot of bits which only signify that it was the wrong place to implement this logic. And when you think along all these ideas that I shared so far, it makes perfectly sense to implement the tool calling as yet another advisor. And what tool calling is, for those that are not familiar, it's one of the most, this may be the second, in addition to advisor, this is the second important concept that you should take away from here, is that most of the foundational AOM nowadays, they've been pre-trained to recognize that if you put some additional information and metadata in your context, like, by the way, have these functions, these tools that can provide you with additional information if you're interested, the AOM can use the opportunity, and if it needs it for a particular task, can, instead of providing the final response, it can send us a special message, say, oh, by the way, can you actually call this function that you have? For example, if you have real-time weather forecast, this metadata would be like, I have tool called real-time weather. The description, which is a very important part of the tool definition, is that hint for the AOM when it should use this tool if necessary. So this can be as simple as real-time information, weather information. And then the third parameter, usually in the metadata, is what are the parameter types that this function takes, often expressed as a JSON schema. So with all this information, AOM can actually decide for a particular case to go back and ask for additional information. Spring API provide the plumbing, and this is exactly the logic I was talking about. It would intercept, dispatch this special message for tool calling, know how to find the right tools, call it, get the information, augment the original context, and try and pass this information to AOM in order to answer the questions. And indeed, this is how it's going to look if you're using the same concept of I was about to say harnessing, which is the same, but advisors. So you're intercepting the output. You check if the output message is not the normal response, but it's a tool calling message. And then implement the same logic. You're dispatching them, you're using the tool call manager, access the response, and put it in your context. So this is interesting bits. The tool call advisor was supposed to support some sort of mini memory or conversation history. And I'm mentioning this because when you start to mixing and matching, combining multiple advisors like the memory and tool calling, you have to be mindful about this detail. And there is an example, but okay, the example is very straightforward. Just let me show how it looks in code. We already used, with the previous example, the concept of tools, because we code the weather, but here is more realistic one. There is different ways in Spring you can define tools. It could be as simple as Java util functions. The most common way, though, is to annotate some methods to add tools. If you use MCP, it would be MCP tools, but the principle is the same. We are going to indicate to the Spring framework that this is supposed to be a tool. A Spring framework is going to take care to convert this into tool description, know how to find and code this tool, and that's in place. So in this case, we're using the real weather third-party application to get information, and we can ask questions like, what should I wear today in Amsterdam and Barcelona? I live nearby Amsterdam. And the response, we would expect we're asking for two really different locations, so I would expect that there will be two calls, indeed, two get temperature calls with the different parameters. That's what we ask. That's what the assistant replied to us with these two call requests. Then the user and the Spring AI dispatched this, resolved, found the right temperature, and returned it back to the model. So this is the dance. Again, the focus is not that much about how tool calling works. It's about that we're using the same principle to implement these capabilities. And when we start to talk about this, allow us to enable much more advanced, interesting patterns, like tool search tool. If you have used MCP servers, it's very easy to overload your system with only tool definition. These bits here can very easily be populated if you have 100 tools or few hundred tools, and that's very common. If you just use only the GitHub MCP server, you end up with a few hundred tools. Then it's very difficult for the AOM to dispatch which tool to use, and also you're wasting a lot of context because you're passing back and forth, practically back, a lot of information and metadata that you might not ever need to use. So how you can solve this problem? Historically, people have been trying to use RAG-like techniques, using the user question to pre-filter what are the tools that might be necessary for this user question, but it turns out that this is a very weak approach because the user question itself might not indicate the intent that, and the real intent that necessary to provide. Just the semantic search is not enough as a mechanism to understand the intent of the user message in order to figure out what are the tools that are responsible. So what you should do, and what actually the tool calling is very powerful, you're delegating this responsibility to the AOM. From the user question, the AOM much better can actually figure out what are the tools and what is the real intent and the real task that needs to be performed in order to figure out what are the tools that would be needed to perform this task. And now, going to the tool search tool, and this is coming into this general pattern of progressive disclosure, data disclosure. I call this progressive tool disclosure. The idea is very simple, but very powerful. Instead of sending all these 100 or few hundred or even 1,000 tools in your metadata and in your single request, or every one and each of your requests to the AOM, you're going to register a single tool called tool search tool that has definition something like this. If you need some additional information, practically informing the AOM that if it needs some additional information, it can actually go back to us and ask for this for these tools to be registered on runtime. And at the same time, when we start the application, we are indexing all are available too on the client side in some sort of tool searchers, and there is a different implementation that still can use semantic search with vector stores, Lucene, even regular expression as simple as those. And now the AOM, let's say we have the same example. We have thousands of services, thousands of tools, and one of them is the real-time weather forecast information. And if we ask the same question, the AOM would come back first and do you have practically tools that provide this real-time information? We're going to retrieve the best matches that we have in our searches, register them to AOM, and now the AOM can actually ask this question. I have a very nice demo that illustrates this in practice. And it's very powerful pattern. We're going to make it part of the release 2.0 coming next month of Spring AI. So right now it's part of the Spring AI community. You already can use it, but feel free to give it a try. Okay, here is the demo. And in order to try to simulate what might look like, I have few good functions, tools. The question I'm going to ask, help me plan what to wear today in Landsmeer. This is a town in the Netherlands. And then I have this, okay, what's important? Please suggest clothing shops that are open right now in the area. So the time is involved as well. So I'm providing a tool that can provide the real time, current time, then weather that provides the weather forecast, but also weather forecast for a particular time. So there is a second additional constraint, and then clothing that is provide potential shops, but again by location and time. So, and those are the useful functions that we want to use, and we are registering them. But in order to overwhelm the definition, I have also these tons of additional tools that are kind of similar, but not exactly, that also register it in our configuration. So if we have used, and actually right now we're using the normal advisor, we would see all those tools. Let's run this and just see how many tools we have registered up front and how many tokens we're going to consume with this. See, up front, we have all these tools that we have available. They are already registered. I presume that AOM would be smart enough to figure out among those that there's still not hundreds of thousands to confuse our model. But most likely they, okay, so, yep, we got the current time, then it's going to ask for weather, and finally it's going to ask for the clothing and resolve the response. And we are going to see how many tokens we have consumed. In this case, something like, yeah, 14Ks. Now let's switch to the new strategy, and everything you have to do is just to use this alternative advisor. Which builds on top of the previous one, and try the same. And it's very interesting to observe what are the conversations and what goes back and forth between us. And so we sent initially, see, we have only single tools pre-registered. The very first things that our AOM did was to ask for current date today. So based on this query and our registered tool searcher, the user figured out that it can provide somehow even the weather matched as a tool description into this category. We returned both. So the assistant asked the weather, the time, because it's prerequisite to ask the next functions. And then we provide the response. The assistant asks the weather information based on the location and the time that we have provided before. We returned from the previous request. Then we provided this response, and at this moment, the assistant also realized that it doesn't have information about the clothing, so it's going to perform a follow-up tool search tool request, now for clothes shops. And here, we smartly replied with this, provided this information back. Now the assistant can ask this clothing and reply this with the same response. And we have, half, in this case, half of the tokens that will be used. So it's a very powerful way and advised way to use, especially if you use a lot of tools and tokens. Explain about agents. This falls, and this is a pattern that actually was borrowed from product and called MemGPT, Letter. How many of you have heard about MemGPT or Letter? Okay, so in short, it was a very early framework for memory, for many agent memory management. Very sophisticated. It uses the same pattern for session, long-term memory stuff, but it comes with very interesting ideas. And one of the ideas was that let's say that you have a tool code, that's the weather one, that has this location information, but you also would like to figure out why the LLM actually code this tool when it calls it. How are we going to do this? You would like to get information why this tool has been called. One of the common ways, and that's actually how they approach it, you're going to add additional parameter here, like inner thoughts with description. Please provide information why you code this tool. So when the LLM receives this, it's going to fulfill this parameter, and you can actually use it as a meta information to do something smart, although it's completely unrelated with the tool that you're calling itself. So you're just using this as a hijacking to pass this information, which is their approach, but was kind of abusing the idea of a tool itself. So what we did on our side, and in this particular technique, is to augment. You can actually provide a very simple proxy implementation that augments the tool request, and you can register a random number of additional parameters on the way to the LLM. So that, for example, in this case, you can add this inner thoughts parameter, and the LLM, for the LLM, this tool code would look like valid tool code with all this description. It would be obliged to provide the information for all fields here in order to code this tool. So we would go on the way back out information about the reasons why this tool was called. And we can either leave this parameter, or as normally you would do, you're going to drop it, but you can have a handler to actually act upon this. This is very common things if you want to do some observability on this. And in code, so behind this proxy, the rest is the same, code request. And in code, it would look something like this. You just can, and this works perfectly fine with any tools, both local and MCP tools. I'm looking for augmenter. And again, this is already in the Spring code, my milestone 4. So here is our original tool definitions. As you know, single location. What we would like to inject additionally with this tool is this additional parameter, inner thought. See your step-by-step reasonings of why you are calling this tool. And just for the randomness, I also provided this parameter, some confidence or additional memory thoughts. And what you're doing under the hood, instead of passing the original tool, the definition of this class to the chat client, you're going to wrap it first into this augmenter and say, okay, by the way, augment those tools, but with these additional parameters. And under the hood, this is yet another tool called provider, so it's a normal abstraction of Spring AI, and you also can register your consumers that are going to act upon these special additional parameters, like thinking, inner thoughts, confidence, everything that we are asking in addition. And if you run this, okay, here we are. So here is the response of our reasoning. So LM reasoning, the user is asking to, for the current weather in Paris, this is a straightforward weather query, blah, 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 blah. So the confidence, high, so everything you might, so, but this is dynamic way you can actually enrich and provide some additional information while interacting with the LM agent. Most of the time it would be some additional observability. And here we're entering in another very interesting pattern in the same group of progressive disclosure. This is interesting topic in general, the topic of progressive disclosure. If you remember, I mentioned about the RAG and the context stuffing early on, where you try to upfront preload your context with everything relevant to your question, hoping that this would be enough to yield the right response. So you're doing the best manipulation in order to restrict and extract the context that makes sense for this question, in order to augment this question, in order to provide the right response. But you did not evolve the LLM in order to make this decision. And this very often leads to overloading the context, or sometimes not providing the required information, although you did your best. So the alternative to this is, let's keep the context up front as small as possible, and let the LLM decide what to get next, to put next in the context. So the previous pattern to search tool was doing the same principle, so you do not preload all tools definition up front. You're letting the LLM to decide which tool to add for any particular task. Agent skill, very popular techniques lately, actually solves the same problem. Try to solve the same problem for the context in general. So do not preload your context up front with various important for you information, but let the LLM decide what is important and what it needs for particular task to do. And under the hood, it is straightforward concept. You can provide the LLM with information like what skills I have. Actually, this additional information that you can plug into your context on demand is expressed like a skill name and description, which is very similar, like the two hints the LLM when it should ask you to get this additional information plugged into the context. So, and this is the metadata of your skill MD files, and the context of the markdown file itself is the actual information that you're going to plug into your context on demand. There is much more coming on. So initially, you're creating a catalog when you start your application with these names and description of all skills that you can have. Normally, it's a file systems with such structure. We also support, James Ward implemented the agent jars, where actually you can package this as a jars. And now Thomas actually has proposal, I know on the specs, to introduce OCI as a packaging mechanism uniform. So there's different way how we do, and there is an open PR on the agent skills that ask to provide a generic SPI to plug any possible. So it's interesting. It goes beyond the specification, but apparently there is a demand to have different way to express and to consume those skills. But the principle is the same. You're letting the LLM to know about the existence of these skills, what they can do, and LLM can actually ask for more information. Spring AI implements the specification. It started again with Claude initial idea, and then it was donated, and there is a sort of like a foundation or specification that manages this. You can go here to find it, and Spring is one of the adopters of this specification. I mentioned agent skills, another way to wrap these bits, and what it does underneath, and this is another important bit to understand, it's nothing more than yet another set of tools. So it is powerful concept, but how you're implementing underneath, you have a special skill tools that actually can listen, it advertises itself, and actually can list all available schools that have skills metadata that have been provided, and LLM can on demand ask for additional information by hitting these skill tools, and the skill tools is going to load the rest of the body of this skill itself. I'm going to run the demo itself in a bit, but before I get there, this is the very basic idea of the skills. The skill itself can have a reference to other files, and this again falls in the concept of progressive disclosure. You do not try to preload the entire information in your skills. You just provide the highlights. And if there is some additional branches of how the LLM should follow, you can provide this as additional markdown files, and the LLM is going to follow up and actually read these files. And what is scariest part in how it is, you can even provide scripts that the LLM can use in order to fulfill and to support these skills that are running in your local machines. And for this, you would have to provide tools like Bash to enable this execution. And if you do this, you definitely have to run your application in some sandbox or container environment. And this is exactly what I'm not going to do right now for my demo. So here is the example, the skills. Let's see first. I have a couple of predefined skills. This is one I downloaded from Claude, I guess, one of the default one. This is the format. See, name, description. You can have some additional metadata as well, and this is the actual content of the skill. The skill itself can refer to some additional files and additional scripts. And I have this kind of community-defined skills that is supposed to help you to generate some tutorials, and it also is using a YouTube Python script transcriber in the process. So let's run this, let's run this. How you configure it in Spring AI, it's yet another locations that you can pass, or you can add a special dependency to a jar if you're using agent jars capabilities. In this case, this is the question. So when you're building your application, you're just defining yet another tools. This is the skill tools that I mentioned, and it takes the list of directory where you have your skill defined, and it's entirely compatible with any skills you can get out there right now. So it can be very scary if you allow it to do everything in your machine. I did, and yeah, it actually runs scripts, generates Java code, compiles it, runs it. yeah, it is quite impressive and scary at the same time. So everything here out there works. So that's what we do. We are actually adding these tools. And also, because we want to let it run shell scripts on our machines, so we enable the shell tools. We also want to allow you to ask additional information, which additional markdown files. We also enable the file system tools. And this is unrelevant. If it needs to get some additional information from internet, this is also tools that we provide out of the box, Brave Search or stuff. So let's run it, and the question we're going to ask, explain reinforcement learning in simple terms, and even referring to some YouTube videos. And I would expect now a lot of things to happen under the hood, including executing this, running this script. Okay, so it immediately realized that it needs this skill in order to answer our questions. So that's what we preloaded this information, and now it will be back and forth. Okay, we're already starting executing bash scripts. Come on. One of the benefits of using Spring AI to using agent skills is that you can actually use it across various models. And in this case, we're using Anthropic, but yeah, OpenAI, Google Gen AI, Bedrock would work almost equally the same. And eventually, it did the transcripting, it ran the bash scripts, I believe, and we have the response. I think you get some ideas about. By the way, we're a very small audience, so if you have any questions, feel free to ask as we go. So I don't mind answering right now. Another interesting pattern is called to do right, and it falls into the group of when you when you have a question or a kind of complex task to solve, and you ask a question that requires complex path and multiple steps to resolve, some of the agent models can get confused on the way to the answering, so performing too many intermediate steps, and they can lose the track of what actually was supposed to be done in certain points. So in order to enforce them and to force them to actually follow certain path and structure, what you can do is to ask them to create a to-do list up front with certain structure, and then you can ask in the same system prompt that you define this logic, always perform one step at a time the items that this to-do list is following have a very simple life cycle, pending, in progress, and completed. So you can also enforce in your system message that the LM should not progress to the next task in the to-do list before the previous one has been completed. And in this way, if you have complicated tasks, you can enforce and make sure that the LM always follows and completes all steps in the process. It's very simple pattern again, because from our side, we just introduce one dummy tool that even doesn't retain the state if you don't want it. From our standpoint, it's really not important that much, apart from, for example, visualizing what's happening as a steps. But for the LM, this really brings and enforces some sort of structure, and it's using the to-do right combined with memory in order to ensure this progress on time. So it's easier to show in code than actually this diagram. To the right. So that's what we have. It's yet another tool we're defining in our system. In this case, we are going also to define a memory to support, and we have two co-advisors. You can see also that we are mixing and chaining two co-advisors in order to fulfill some greater goal. And in this case, okay, we have very simple request-response loop. And I think I have some challenging question here that hopefully would force the LM to perform multiple steps. I knew it. Good luck. Okay. So, Okay, so now you see, actually it goes, and what I didn't show, I also plugged some UI callbacks that I'm using just to visualize what's happening. So it started with first task, it completed it, it moved to the second task, and when it's going to complete it, it is going to, so this is a technique to ensure that I'm actually always going to do the task in the right order and it's not going to skip something on the way out. And again, this is a pattern that I actually borrowed from the Cloud Code itself implementation. It was something, interestingly, the last version of the Cloud Code actually moves away from this pattern because they actually re-implemented some of this logic in their new task management mechanism, but the idea is the same. You are actually forcing the LM to follow a certain path and not forget the steps and always move to the next step after the previous has been completed. And here we are kind of stuck. No, actually, oh, this is the old demo. Sorry. Let's remove these bits. So, next. This is another simple pattern which does something similar. Very often the LM are going opinionated. If you ask a complex or any question, they will tend to make assumption and go forward. And once they moved forward, it's very hard to force them to come back and to actually correct what you intended them to do. What you can make in order to improve this interaction, it could be some sort of like elicitation. You can ask them or ask the LM to ask for additional questions, clarification questions, before actually it makes the final decision. So in code, again, it's yet another tool that you implement with this special description telling the LM, by the way, if you're not sure about how to proceed or have multiple choices, don't make opinionated decision, ask us for details. And there is a certain format that the LM can ask you, usually a multiple choice with also free text. And Spring AI provides out-of-the-box handlers. You're supposed to plug in the handlers. So Spring AI provides out-of-the-box handler for the command line implementation. But if you have some special UI framework, you would have to provide this handler yourself. And let's see again how this looks in code. Again, this is yet another tool. Ask user question. We are registering in our system. We have the tool co-advisor, we have the memory, and again, the same loop. Let's run this. And what, okay. Should I visit next? Without adding this tool, most likely the LM is going to make some assumption and give me some suggestions based on no context at all. Now, because we have these bits, we're going to get some question for, okay, nature and outdoor, let's say. Warm Mediterranean, okay. Luxury, oh. Okay, let's, maybe, okay. And now apparently those were the initial, oh, what I did. Maybe I should have picked luxury, I guess.
I think there was no option for others. Expected one of those.
So this is slightly different question. I didn't mention EU, so I think it would get different set of responses. Okay. Okay, culture, warm, luxury. Ah, okay. Okay, let's reduce ourselves. So, but you get the idea. Hopefully now it would provide us with a response. Well, we get there. I'm going to touch upon yet another pattern, and I think we're going to stop there. It's called sub-agents. Okay, we have the response here. So what are the suggestions? Spain, okay. Malta, not bad. Italy. Okay, I think we're in a good company. Sub-agents. This is yet another, if you remember, we already discussed about the context progressive disclosure and how to optimize the context with the tool search tool, with agent skill that helps you to segregate the context before or actually ask the context of demand. Sub-agents and other techniques that tries to manage and to keep the context clean. And the idea is that if you have a complex task, in order to solve the complex task, the LLM would have to solve a lot of small subtasks. In order to solve this subtask, very often it's going to use tools, additional tools, additional skills, and it's going to pollute your main agent or lead agent context, which would decrease the chance and the ability of this agent to solve and to provide the right response. The solution is kind of straightforward. Let's run this subtask in their isolated context. And this is the idea of the subtask. Under the hood is yet another task tool that you can be configured to run a task, which are defined in Markdown, very similar like agent skills, with front matter metadata, name of the task, the description, what it does. You can actually have dedicated model. Very often the subtask would run in their small, faster model dedicated and specialized for this particular task. And only the response they run in their isolated context, and only the response, the result of this task execution, subtask or sub-agent execution, is going to be returned and added to the original context. Spring AI extends this concept. Practically, in addition to this local definition, you can actually plug and define A2A agent description as well. And I maybe have, oh, this is indeed the diagram. You have them. I would share the source code for this and many other demos you can run, and then this is one of the more extended one. I wouldn't have time to get you there. Just wanted to point out that the concept of this advisor that we discussed is, to recap, we built everything with advisors, with one small exception, the tool co-advisor, which also relies on the ability of the LLM to execute tools. So two advisors are practically advisors, and the tool support is everything you need to implement all of these patterns that we I demonstrated so far. And then it's very important to order them in right order. Here is the last thing I'm going to share. This was the tool co-advisor and the memory. So with the tool co-advisor as an advisor, you can actually use the memory to intercept the input and output. And this is the concept of the tool request and response, something that was not possible before with the old implementation of the tool handling. And what is important is the order. See, in this case, in order for this to happen, your memory advisor should be inside your tool co-advisor. If you change the order, it's still going to work, but it will be the old behavior. The memory is going to also only to memorize your original request and final response. With this, I'm open for questions. If you have, actually, there is no questions. You can send the questions, and I'm open for discussion afterwards. So thank you very much for the patience.